LeetCode Problem number 1851, minimum interval to include each query. So we are given a 2D integer array called intervals, where each intervals have their own left and right or start and end. So it's inclusive. The size of an interval is defined as right minus left plus 1. Right. So if our interval is 1 and 4, so right in this case is 4 minus left 1. 4 minus 1 is 3. 3 plus 1 is 4. So meaning this would have a size of 4. So we're also given an integer array called queries, and basically what it wants us to do is to find the size of the smallest interval I, such as the query would fit in between the left and right intervals. If there are no such intervals, we will return with a -1. I have to return an array containing the answers to the query. So let me show you how I've done it. So let's say I'm going to use the intervals here, and the queries I'll be using this as well. Okay, let me give another one, let's say 7. Right. Okay, so the first thing I do, I have queue size, which is the size of the query, which is 5 in this case. Here I construct a result vector with queue size in mind. So this result is what we will be using to return. And here I have a pair called query pairs, right? So this query pair will store the query itself and the index of where it's located at. Okay, so what I mean by that is over here for every single query in my queries, I would place them back. So my query will look something like this. So this is 2, 0, 3, 0, 4, 0, 5, 0, 3, 1, 4, 2, 5, 3, and then 7, 4. So if you see here, 2, 3, 4, 5, 7 responds to the queries, and 0, 1, 2, 3, 4 would make it their index, right? So the reason we need this is because I'll be sorting the queries, because queries, if you notice, they could be they could be non-sorted. For example, like this 219, 522. So that's why we need to sort it, and later on when we push it back into the result, we need to know the index of which exact query we are working with. That's why we need to keep track of that. Okay, so here I'm sorting the intervals by the starting number, and since this is already started, so it will sort as so. But if let's say this is over here, for example, then obviously this will be moved to the back. Right. Once I'm done with that, I sort the query pairs as well. So since it is already sorted, so this will not move as much. But let's say if 7 were to be over here, actually let's just do that. Right. So I'll move 7, and then 3, 4, 5. Okay, so I will need to sort this. So queries. So I will actually be sorting the query pair. So this will be moved to the back. Right, you can see the index is still 1. Right, that's where the query 7 is located in the queries. So again, this is the example we're working with. And here I have a priority queue. So this priority queue will basically keep track of the intervals that are suitable for our current query. And the reason why we need to keep track of that is so we can compare and take the one with the least size. Right. So this priority queue will store again. I'll explain more on how it will work in a bit, but for now it will be empty. I have a J as well. So J. This J is just a index, keeping track of the intervals, right? And I have the current query, which is basically the first and second, and I have an index, which is the second. Again, if you remember, query pairs will contain the query in the first and the index in the second, right? So I'll leave that as is for now. J0 query. For now, query is the first pair, which is 2. And we have index at 0, right? So this is all of the variables we'll be working with. So here first, while j is less than interval size, so meaning we are iterating the intervals, and we are checking whether or not the start is smaller or equals than the query. Right. So what this means is if this interval start is smaller than our query, meaning that this query can fit inside our intervals, right? So since this interval can fit 1, 4, since query is 2, so what we'll do is we are pushing, okay, so here, you notice that we are pushing a pair, right, because priority queue is a pair. So what we're doing is we are pushing a pair, right? So this pair will basically contain the size, right? So the size of this is 4 minus 1, 4 minus 1 plus 1, right? So this is actually 4. While the second value is the n, right, which is 4. Okay, it's 4 as well, the n. J will iterate, J will increment, sorry. So J increments, now we're looking at the next one. It's 2, 4. Since 2, 4, again, it's inclusive, so the query 2 can fit inside of this interval. So again, we are pushing back 4 minus 2 plus 1. So this will give us 3. And the n would be 4 over here. Okay. Now j will increment once more to 2. Now if you look here, since the start is 3, okay, I forgot. Actually, no, I didn't forget anything. Yeah. But this 3 here would then cannot fit into our current query, which is 2. Right, so yeah, which is 2, right? So we can't, so we are skipping that, meaning this while loop will end. And now we are looking at this other while loop. So this other while loop, for now, it does not do anything because it is only checking the priority queue top, right? The second value, which is the n, whether or not it is smaller than the query, meaning that our query actually falls outside of the range on the right side of the interval. But since we just did this, and this is our first pairs, so this while loop does not do anything for now. And here I'm updating the result. I'm updating the result index, and since this is a priority queue, so if you remember, priority queue would sort it based on the smallest number at the top, right? That's something I forgot to do just now, but since this is a smaller interval than the first one, right? 2, 4 is smaller than 1, 4. So what we do is we put the index, if you remember, index was 0. So the result 0 here would actually be the top's first 3, right? Because the priority queue for now is empty, right? It's not empty, sorry. It's not empty, that's why we are giving the top of the priority queue. Okay, so we have our first index done. Next, tree2, update tree2. So I increments. I forgot to do I, but basically, yeah, is this query pair right here. Let's do it. I is 1, right? So right here, 3, 2. Okay, again, this for loop will check whether or not the interval start, which is j is 2, right? So 0, 1, 2, this start 3, 6 is actually inclusive of our current query, which is 3, right? And since it is, so we will need to push this into our priority queue. So we need to push 3 and we need to push this actually 3, 6. So this is actually 6 minus 3 with 6 plus 1. So this will actually be 4 and 6 again, right? Okay, j increments to 3, and if you look at the last intervals, 4 is bigger than 3, so we don't do anything there. Our priority queue, no, not priority queue, this while loop will stop and this other while loop will start, right? So this is basically again checking whether or not the current query 3 falls outside of the range of our n in our intervals, right? And since it does not, so we don't need to do anything here. And here we are putting the index, if you remember, it was 2. So 2 is over here. So 2 is tops first, right? Top first would be 3. Okay, once that is done, I will increment to 2. Our query is now 4, while the n index is 3. Okay, again, this while loop will start back up. So this 4, if you notice, is actually inclusive of our intervals, right? Because this 4, the start of our intervals 4 is equals to our query, which is 4 as well. So we're pushing this into our query. So if we push this, we notice 4 minus 4 plus 1 with the n, which is 4. So this will give us minus 3 minus 1, right? And it will be moved up because this is a priority queue of 1, 4. Once that is done, this while loop will end because j has reached the end of the intervals. We have iterated through all of the intervals. So technically for now on, we can just skip this while loop to speeding things up a bit. Okay, again, this while loop does not do anything for now because our current query 4 actually still falls within range of the priority queue, right? So this 4 is not smaller than our current query, this 4. Okay, again, we update the index. Index is 3, so we're looking to replace this 0, this specific 0 here, with the tops first, which is, in this case, 1. Alright, now after that I increments to 3, and now we're looking at 5, 4. Okay, so I'll update here, 5, 4. This wallet will not trigger anymore because j now is actually bigger than the, or more like equals to the size of the intervals, which is 4. So this while loop will never run anymore to the rest of the programmer for this specific. Okay, now this while loop, if you notice, the tops second 4 is now smaller than our current query, right? 4 is smaller than 5. So what this means is this starting is 5, cannot fit into this interval, right? So we will have to pop this entry, right? Basically, we have to pop all the entries as long as it is smaller than, as long as the end of all of these, if you notice 4, 4, and 4, they are all smaller than the starting query, right? Meaning that they can't fit into the intervals, so we can just pop these out. Once we're left with this, 6 is now no longer smaller than 5. So this for loop will end and update the results. Result index is 4, so we're updating this, and you can see the end is actually 4, right? Okay, now we're done with that. Query, or more like I will increment once more to reach our last query, 7.1. Query is now 7, index is 1. This for loop does not run, and here this while loop, you can see the top second, which is 1, is actually smaller. No, sorry, top second is this, right? 6. This 6 is smaller than our query, 7, right? 6 is smaller than 7. So we will pop this, and once we do, this priority queue is empty. So this for loop will stop, and here we are putting the result. So result of index 1, so this specific query, since the priority queue is now empty, we'll be putting in -1, meaning that there is no suitable interval that we can fit this query in. So once that is done, I will increment again to 5, and since 5 falls outside of the range of our query pair, we have reached the end. And if you see here, we return the result, which in this case is 3, -1, 3, 1, 4. And if we can look back at the output in the examples given, 3314, 3314, but because of this 7 we have inputted just now, we get a -1, because this 7 has no available intervals for us to query from. Okay, so this problem might look a bit complicated, but once you know the trick, it's really not that difficult to execute. Okay, that's all I have to show. Thanks.